Hi, today we're going to be doing the lesson 4.1, Solving Polynomial Equations. The goal of today's lesson is to solve polynomial equations using a variety of strategies. So if we take a look at this first example, we've got, first of all, for example A, f of x equals x, quantity x minus 2 squared, quantity x plus 5. So we just want to state the zeros for this function. Okay, so if we just take a look at each of the factors, if we're stating the zeros, that means that y equals 0, and y equals 0 corresponds to the x-axis. So then if this entire thing equals 0, then that means that if we're multiplying each of these different powers together, each of these different factors together, and we get 0, that means that either x equals 0, or x minus 2 squared equals 0, or x plus 5 equals 0. Okay, so for the zeros now, we see quite plainly that x equals 0. So that's 1, 0. X minus 2 squared equals 0. So we can take the square root of both sides, so we get x minus 2 equals 0. And therefore x equals 2. So we have two zeros, x equals 0 and x equals 2. And then we also see that x plus 5 could equal 0, so then x equals negative 5. Okay, so therefore the zeros are x equals negative 5, 0, and 2. So the same thing goes for example B. If we're trying to find the zeros, we're trying to find the x-intercepts, and the x-intercepts occur when y equals 0. So if we've got two factors and they multiply together and give you 0, that means that either x cubed minus 1 equals 0, or x minus 17 equals 0. So we just have to solve both of these. So we got x cubed equals 1, take the cube root of both sides, therefore x equals 1, and over here x equals 17. So therefore the zeros are x equals 1 and 17. Now we go to determining the roots of this equation algebraically by factoring. So first thing we want to do, because we're trying to find the roots, that means we're trying to find the zeros, or the possible zeros. And so we saw in this first example that the zeros occur when y equals 0, because that occurs at the x-axis. So what we can do here is rearrange this equation and set that equal to 0. So when we do that, we would get 2x cubed minus 5x squared minus 4x plus 3 equals 0. So I'm going to let f of x equal 2x cubed minus 5x squared minus 4x plus 3. And because I don't think I can factor this very well as it is, I'm going to use the factor theorem to figure out what a possible factor of this could be. So please pause the video and find your factors using the factor theorem. Okay, so now that you've done that, I have gone through and worked out f of 1 equals negative 4. F of negative 1 equals 0. So therefore, x plus 1 is a factor. And I could put that in brackets to make it a little bit more compact. And so now I'll use synthetic division. So go ahead and please do your synthetic division for this to find a quadratic that you might need to end up factoring this more completely. So with synthetic division, we're going to set that up like that. Bring down the 2, multiply, add, multiply, add, multiply, and add to get 0. So that works out perfectly, so the remainder of 0, just like we found with the remainder theorem here. So now f of x equals x plus 1, 2x squared minus 7x plus 3. And then we take a look at this, and we can factor that. We can use sum across products or decomposition, however you like. So please factor this quadratic, 2x squared minus 7x plus 3, and come back to check your results. So this then results to be x plus 1, x minus 3, and 2x minus 1. So therefore the zeros are x equals negative 1, 3, and 1/2. Now there are times when we have a 4th degree polynomial that we need to find, we need to factor, but we don't always necessarily have to use the factor theorem. Sometimes we can take a look at it and we might actually be able to factor this by grouping. Okay? So the one thing that's important though when you do factor by grouping is to make sure that when you do group things and you factor them out the first time, that you do the first common factor, that the remaining brackets are equal to each other. Okay, so we'll see that in a second. So why don't you give this a try, group them in pairs, and then do a common factor and see if those two brackets are equal. If they are, then common factor what's common out of those two resulting terms, and then that would be a way of factoring by grouping, and then we'll be able to find the zeros.